Now remember, I've got a 5x5 grid up here. That doesn't mean that you have to have a 5x5 grid for your paper. You use however many boxes and whatever scale you need to. Okay. I saw those ones. Where'd he go? That one. That one. Remember, you got enough tools now. You can graph this however you want to. Some of us like to rearrange and be in slope intercepts. Some of us like to graph by intercepts. You do you. Who's got it? McCree's got one. Right? 3, 4.5. 4.5, 6. All right. Who else? Work wouldn't have it. He wouldn't have it. Yeah, 6. Okay. Cool. Curious, how many of you, just wondering, thinking about next year, how many of you have signed up for both Algebra 1 and Geometry? Okay. All right. Because kids can come in as a freshman into Algebra 1, and all freshmen are required to do it every other day class. But because we have some kids who will take Algebra 1, or the back half of Algebra 1 as a sophomore, we allow you to start doubling up, because up until the last couple of years, that's been all of our math classes. So those of you who did register for both, next week, literally a week from today, advisory on the 17th, you're going to get your paper schedule. And paper schedule will have, those are the classes you're taking and when for next year. Do not go running down to the guidance office to go changing anything, because they ain't going to be in there. That's the 8 to 9 transition day like you all did last year. That's where a whole pack of runts comes up here and they take them on a tour around the school and generally be knuckleheads, and all the big kids scare them, that kind of stuff. But you will get your schedule next week, and I just double checked. It's kind of a grab bag who you're going to get. Jameson has all but one of the every other day Algebra 1s. So if you are just in Algebra 1 next year, you're probably going to be with Jameson. McCreary has, I think, one of those sections as well. So it's like a 75-25 chance. If you did every day for one semester to double up and then do geometry, it's a 50-50 shot whether you have McCreary or Spear for Algebra 1. Okay, so just letting you know kind of an idea of where you're headed. I would vouch for all three of them. I'd say they're all solid. McCreary needs to assign a little less work. We've been working on it with that, but yeah, just thinking about the schedule, because whoa, we're almost there. How many of you rearrange this? Like, slope intercept is my jam. I shall live and die by the sword. Okay, a couple of us? All right. So if you did that, you would have subtracted 5x, but you have to be so careful here, because if you did, that's negative 3y less than negative 5x plus 18. Remember your training, young Jedi, last semester. What happens when I divide by a negative? Okay, my inequality has to flop directions. And I have to divide all three of them by that. So I'd get 5/3 x minus 6. But I have to flip the inequality. Okay, so if you did that, you would start down at negative 6. I think I got enough room to go just a hair off-road here. So I'd start down at negative 6. Womp. And from there, up 5/3. 5/3. or up 2.5 over 1.5, since I don't have enough room to make more points. So up 2.5 over 1.5, up 2.5 over 1.5. Did I miscount? That's 1, 2.5 over 1.5. Up 2, okay, I miscounted the second time. Or, option 2, I could have just done my x and y intercepts. Jam is 0 in for y. X-intercept of 18/5. 18/5 is 3 3/5, or 3.6. So if I just have a x-intercept of 18/5, or 3.6, I think y'all could ballpark 3.6 on number line. Y-intercept, throw in a 0 for x, divide, get a y-intercept of -6. So I could y-intercept of -6 and x-intercept of 3.6-ish, and you see it's right there on that line anyway. I'm showing both because looks like we're about a 50-50 split on how you graphed it. You should have solid or dotted line. Less ink here, less ink there. Okay. And if I plug in 0, 0, 0 less than 18? Yeah, last I checked. Last I checked, newborn is younger than adult. So if that is a solution, that means everything on that side is a solution. Additionally, if I had rearranged it and I remembered to flip the inequality, that just says y is greater than the line. Right? Y's are greater than line above line. Well, that also points in the same direction, so you should have everything over here. I'm not going to spend the next 2 minutes coloring the board. Okay? So, in terms of our points, A, whichever way you did it, you were going to have that y-intercept. You had to, because slope-intercept form and graph by intercepts both use that point. For part B, for round 2, I'm going to say either you had the correct x-intercept of 18/5, or you had the correct slope of 5/3, because either of them are going to get you to that point. Did you have the dotted line instead of solid? Did you shade in the correct direction? And then I'm going to leave one floating for, look, I did all that. I did all the stuff, but I don't know, I missed my negative back here. Like, I even remembered to flip the inequality. I even shaded the right way and everything was going to go great, but then I forgot my negative. Okay, we always get that one whoopsie. So 1 for somewhere back in your work if you did the whoopsie, 1 for the shading, 1 for the line, 1 for the x, 1 for the y. Okay, anything about it? How'd you feel about this stuff? Like, if you can graph a line, you can do this, right? It's just solid or dotted, and which way do I shade? I didn't have anyone ask any questions, and I'm in the middle of grade-a-thon here. I forgot to pull up the book, so you tell me, was there anything from the homework? I'm betting if there is, it's ew words. That's my guy right there. He's already got the book. He's prepared. What do we got? Okay, 30. So we're cool with the graphing part. It's how do I turn words into math? All right. So you budget $200 for wooden planks for outdoor furniture, Call that more like 500 now. Cedar cost, oh yeah, if you're doing cedar, geez. Cedar costs $2.50 per foot and pine is $1.75. Let X be the number of cedar, Y is the number of pine, linear feet. What is an inequality that shows how much of each? See how they gave you a rate for both? They said this costs $2.75 per foot. That's my big keyword there. Whenever I hear per or each, it tells me this is a rate. So they said something X, something Y, and they gave me a total. You have 200 bucks. Can you spend exactly 200? So what does that mean? Or equal to. So I'm going to have or equal to because I can spend exactly that amount. And since that's my budget, less than or equal to. And then you go look for your rate. Again, they said that X was going to be cedar, Y was going to be pine. So the rate that they give for cedar and the rate that they give for pine. That very first sentence, when they told me you budget this much, they didn't come out and say the word total, but we know that's my total. When I think about that first time that you got a gift card from grandma for Christmas. You know, you hit that age where they don't know what to get you anymore, so just here's 50 bucks to Target. Like, I'm king of the world, right? I get to go there and I get to buy this and I want to buy this and I want to buy this and no, that's like 70 bucks. Like, you can't do that. That total, we know that a budget is a total. You done budget stuff in any of your classes talking about like, you know, after high school? Yeah. Like, what would a budget be if you had to pay $1,200 a month for rent and you had to pay $150 a month for your cell phone internet combo and you had to pay this much, you had to pay this much? How much is groceries? Have you ever done anything like that in any of your classes? Okay. Um, Personal finance. You'll take that as a junior or senior with Miss Leitenberg. You do a little bit of in there. If you're going to do this class, Algebra 1, next year, and then either geometry to business math or straight to business math, depending on your graduation plan. I know that in the business math class with Mr. Keeler, they do a good chunk of that kind of stuff. Like, I think that's even part of it is plan a road trip and you have to budget stuff. We should know budget is a total. And total fits that form that we've been talking about for a while now. Rate X, rate Y is total. They really like those for systems. Okay? Anything besides E words? How do you do with working backwards? There was one where they gave you the graph and you had to say solid or dotted line means whether it's or equal to. Do I shade above the line or below the line? Tells me whether it's greater than or less than. Like, eh? Okay, so what if I just threw a random thing up here and said, hmm, hmm, hmm. Let's start with that then, because that's a good warm-up leading into today's. Scratch it out in a margin, on the corner of your notebook, something. Tell me, what is that inequality? My line's not the greatest. That goes through the 0.02, by the way. Okay. Okay, what is your slope? Where's your rise and run? Where's your y-intercept? Did we shade above or below? Solid or dotted? It's kind of that series of 4 questions. Okay, shouldn't be too bad. You say y. Am I shading above or below the line? So, less than line. Solid or dotted tells me whether I fill in this line or not. Less ink there, less ink here. I see I started at +2, and I see a rise of up 3, right 1. Up 3, right 1. Up 3, right 1. That's 3 and 1. We always go to the right, and whether I'm headed up or down tells me whether it's positive or negative. Putting it all together, y is less than 3x plus 2. Okay? Doesn't have to be rocket surgery. Like, it's not that hard if you just break it down to its little parts. So, if you could do that, if you were fine with Friday's stuff, today's going to be no problem. Now, I've got 3 different grids here. I want you to start by, don't shade, graph both of these lines here and here and here. I want you to do it on all 3. There's a method to the madness. Both lines here, both lines here, both lines here. But the nice part is, after you do it once, you just copy it. But there's a reason, okay? There really is a reason. This isn't like back when you're in elementary school. I want you to copy down this sentence 15 times. I don't know, do they still do that kind of crap? Punishment, do they still do that? The whole class was bad, so you have to write this sentence like 38 times. God, drove me nuts. No.
My sister's learning how to times fractions right now.
Okay, that skill and drill, I understand that. I'm talking about, do they still do that as punishment? Like, that was Bart Simpson style.
Yeah, I have.
Okay. Okay, I'm not just doing that. There's a reason. Okay. So, contestant 1. Start at -3, slope is 2. Up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Or down 2, left 1. So I'm going to do that over and over. Okay, no shading yet. Just that. Okay, contestant 2. If I go by intercepts, remember, 0 for y, x-intercept is 1. 0 for x, y-intercept is 2. And that gives you a slope of down 2, right 1. Down 2, right 1, down 2, right 1. Up 2, left 1. More ink here means more ink here. Less ink there means, again, less ink here. Oh. Okay. So once you got all three on there, we're going to talk about what kind of the heart of today is. And, well, it's a matter of how neat you are. How neat you are. I want everyone to think about the graphs that you make for your daily quiz and your homework. Do you have the BS little sketch graph that's not really a graph and wonder why you keep getting 20 out of 25 on your homework? Do you have the, well, it's kind of a line? Do you actually use a straight edge? Do you use graph paper? Are you neat or not? Were you the kid who could color in the lines or not? Here's what I mean. For this one, we're going to shade completely the way the book wants us to. Okay, yellow, there we go. So for contestant number 1, do you see what I mean about y is less than the line? Okay, only works when you're in slope-intercept form though. Y is less than the line. So I'm going to shade everything less than the line. So I want you to shade everything less than the line. You're like, where is this going? Are we just doing coloring today? Like, what the? Come on. All right, blue. Well, blue doesn't have slope-intercept form, but I can just nicely put 0 in for x and y, that's a 2, and say, is 0 greater than 2? No. So if 0 is not a solution, nothing on this side of the line is a solution. You shade the other side. So, okay, shade the other side of the blue line. You always got the kid who's got the highlighters. I love it. Okay. Now, you probably got it figured out by now. Just like when we first learned to do systems, I had said this line is all the places that have Mexican food. This line is all the places that got gringo food. This dot, Guadalajara's in their gringo menu. My wife can get her big honkin' enchilada in a box thing. It's overflowing with, you know, the rice and the beans and it's just this pile of mush that freaks me out. I can get a chicken sandwich. It was the one place that makes everyone happy. Do you got the idea what's happening here? Everything down here makes yellow line happy. Everything up here makes blue line happy. So what's the solution to a system of two inequalities? Everything that way, I feel like I'm like Sub-Zero. Okay. Everything on this side is the solution. So here's why I'm not a fan of this method. Because then I want you to look at your paper. Can you actually tell that that's the solution? And then you got that kid. You know who that kid is. They just come along and they darken the living crap out of this. And it looks like they murdered their paper. Like their pencil was just all over it. Would you be able to tell where your solution is if you did that? Lightly shade this way, lightly shade that way, darken the living crap out of this spot. You would be able to tell where your answer is, right? So that's one way. Another way that I've seen taught, again, I'm not a fan of A or B, is we called it the Waffle method, or the Crosshatch method, where kind of like this, I shaded below this line. So I'll just make a bunch of light lines going that way. The blue line, I shaded above it. So I'll make a bunch of light lines going that way. And wherever you get the waffle, the crosshatch, that's your answer. So you would only shade that area. I would shade wherever I see that waffle pattern. Still looks kind of messy, right? A little too much going on. Now, I said I normally have Algebra 2 and up. We're doing 3 to 7 of these inequalities on a single graph. Do you see how just 2 kind of looks messy? Imagine if you had to do 3 or 4 or 5 of these on one graph. You wouldn't know what's what. So what we came up with was kind of like air traffic controller arrows. If I'm supposed to shade below this line, could I just make a couple of little arrows? Say, go that way. And I'm supposed to shade above this line. I'm just going to make a couple of little arrows and say, go that way. Can you still see where all of them are pointing without making such a big mess? Okay, shade where they're all pointing. So you really step back and you look at these 3. All 3 are valid methods. I will take all 3. But I wanted to show you all 3 because have you ever seen this before? Okay, probably not. I don't think you would ever have a linear inequality in middle school. So they're all correct. In all 3, I can tell where I shaded, but the first 2 get pretty messy, which is why I'm a fan of option C. That's the way that I'm going to do the examples. If you want to do it by methods A or B, you go right ahead. Okay, you do what works for you. But really, that's all the last lesson is. Sometimes we have more than one inequality because sometimes you have more than one constraint. A constraint is a limiting factor. What happens when I say you want to buy some Blu-ray and you want to buy some video games? You got your gift card to Best Buy from grandma. You want to get a couple Blu-rays, you want to get a couple video games. Rate X, rate Y, total. But then you also say, well, I'm going to use grandma's money to actually fund my gifts so I don't have to buy anything for other people. I need to buy at least 3 Blu-rays and 2 games because I'm going to go get gifts for other people. You have multiple constraints and you have that region that is feasible. So these are very, very common. In fact, this is the thing, I think I had told you, Miss McCreary, years ago when she was my student teacher, we did linear programming with this, where we had 4, 5, 6 of these inequalities. And there's a deal where you can find out what maximizes my profit with it. She showed it to her brother who has a graphic arts business or something like that. He uses this now all the time. He's actually using it to make more money. Okay, now we're just learning the foundation. Can you graph that and find, all right, if I got to shade this way and I got to shade that way, this is the wedge that I really care about. So whether you're going to waffle pattern it or just darken the living crap out of it, or you're going to do little air traffic controller arrows, whatever your system is, maybe you got something else. But you have to shade the area that really matters, because that's your answer. It's actually why I don't like methods A and B, because now we've got other stuff shaded that isn't actually my answer. So graph line 1, graph line 2. Where do I shade? Where do I shade? Where are they both happy? I also strongly recommend never do math, especially graphing, in pen. Because what happens when I miss a negative? My slope's going completely the wrong direction. Hmm?
I'm having trouble figuring out how to know which word goes.
Okay.
I don't understand. Like I do, but at the same time I don't.
Say y is what then the line. So this says y is less than or equal to the line.
Mm-hmm.
So for this one,
It would go this way.
I shade down.
Okay.
For
But
this
then that
one,
one you go up.
I shade up.
Alright.
And then you go and fit a few more arrows on there.
Okay.
Like that. Mm-hmm.
I don't feel like this is right.
We got one of our slopes backwards. Because you have to add that 3x over. You can't just move it because you felt like it.
Okay, well that's definitely got me wrong from day one.
Okay. That's why I got up here. I can't just throw that negative 3x on the other side because I felt like it. We spent all of first semester working on equations and inequalities so we won't screw this stuff up. Math scaffolds. You spend all of first half of algebra working on these basic mechanics because you go to algebra 1 and now you're talking about exponential functions, quadratic functions, radicals, rationals, prob stats, complete the square, quadratic formula. You get all these other things that if you don't know the bare mechanics, it gets kind of ugly. Also, I know that maybe not everyone in the room agrees, but You have no idea how lucky you are, how truly fortunate you are that you are able to split algebra into 2 classes, because most school districts, Algebra 1 is a single class, done. And they go a mile wide and an inch deep. They don't get the foundation that they actually need. They don't take the time with stuff. Then they come up to Algebra 2 and just get Sparta kicked in the face. So you get 2 classes to get through all of algebra as intended. That's a good thing. I'm going to do this one since it's already here, blue. I start at -4. Slope is 3. Rise 3, run 1. Rise 3, run 1. Rise 3, run 1. Solid or dotted? Maybe we should actually hit the points. Let's try that again. Better. And then this says y is less than or equal to the line. So that tells me I go to where it hits the y-axis, and y's are smaller below. Since I put an arrow on this side, it tells me it's everything on this side. I'll go do it again. This guy, starting up at 5. Slope is -1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. More ink here means more ink here. Connect the dots. And this says y is greater than or equal to the line. So I shade above that line. And whether you did the light shade or the waffle pattern or the little air traffic controller arrows, they're all pointing into that top right corner. So that's the only part that I need to shade. Okay. Dude, she's just going to wind up and backhand you one of these days. Okay. But do you see what I mean about that's the only area you have to shade? And that's another reason why I'm not a fan of doing the double shading method, because there's folks who will light shade here and they'll light shade here. And depending on the tools at your disposal and how steady your hand is, determines whether I can actually tell that you really meant this. You see how you still have other spaces shaded. This is not my answer. This is not my answer. But I've still got shading there. And that can confuse folks. Like, you know, teenagers, how many times you run into the do what I say, not what I do? Right? This is the rule, but I'm not going to follow the rule. This is the correct answer. When someone keeps telling you things like you should always speak the truth, but not right now, or about this, but you actually shouldn't say that in front of that person. Okay, all of these unwritten rules where theoretically that's the answer, but nah, you're only supposed to tell the truth when you're in this situation. Okay, because otherwise it's going to hurt people's feelings. Right below that, you got 3 more. It is important enough. I know that we can probably do slope-intercept form just fine. What we're having trouble with is if I have to rearrange it or graph by intercepts. So what I want you doing is numbers 4 and 6. Because those each have at least one standard form in them. So whether you rearrange it into slope-intercept form, because that's your jam, or You know how to graph by intercepts. I don't, Kurt. Okay. Whatever method you're choosing, everyone in this room should be able to pick up your paper and tell where is the actual answer.
Oh yeah.
There's a lot of fun stuff on there that we don't show you in Algebra 1. You got to learn how to do it for real before we give you the nuclear launch codes. Right? How many of you done driver's ed? You got to have your permit first before you just go straight for I can drive. You got to drive with an adult before they say, all right, go to Rapid and pick up my tools. And that's only a town of like 70, 80,000. Yes, ma'am.
Okay. So how would I'm confused on my sheet.
Okay. So
So I plug 0 in.
you did these by intercepts?
Yeah.
Okay, cool. So if I plug 0, 0 in here, I get 0 greater than or equal to 1. Is that true?
No. Or yeah. Wait, no. Because 1 is bigger than 0.
Correct. So for this line, and maybe you need to remember that it's this line.
Yeah.
If 0 is not a solution for this line, nothing on that side is a solution. You shade the other way.
Okay.
Do the same thing here. Put 0 in. You get 0 greater than or equal to negative 2. So for this line, 0, is it a solution or not?
No. Well, because, oh, yes it is, because 0 is bigger than 2.
So I will shade towards 0, 0.
So now I shade right here.
And now, since all of my arrows are going to party over in that quadrant,
Thank you.
there you go.
So, what is this telling me right here? That 1 is negative
At 1, negative 3 is a point on line 1. 1, 3 is a point on line 2.
So,
They're using the same set of x's with different y's.
okay. So, this is another problem I'm having, is I don't really know
Shading again?
shading. Yeah, so I know that, okay, so y, so this is your line. This is your line, so the line is greater than y?
Y is less than the line.
So the line is greater than y, too, in a way.
But if I go to, yes.
Okay.
But if I go here to the line, y's are less down.
Oh, because it's less than the line.
Because it's the y-axis,
Yeah.
less than the line.
So then y, right, which is here, it's
Greater than
greater than
that
so
line.
what are you shading here?
Nope.
What?
For this line, I shade up, right? Look at this section, this section, this section, this section.
What's this right here?
There you go. It's where all of the arrows are going to be aiming. spacing there. Please tell me I did the thing. Hey, Goblin is officially one of us. Okay. Those I did, yes. Who else? Bella? Okay. So it sounds like if you know how to graph a line, you're fine with your lines. If you don't know how to graph lines, this is trouble. Shading, hit and miss whether we get that. If I'm going to do this one by intercepts, shove a 0 in for y, divide. X-intercept is 1/2. If I shove a 0 in for x, I see a y-intercept of 1. Now normally, that would not be enough to line up my straight edge on there and get a decent line, because they're too close together. Think of it like trying to snipe someone with a revolver, right? They're 200 yards downfield, and I'm going to give you a little snubby and say, okay, get them. And it doesn't work that way. But I do see a slope of down 1/2. I can use that to extend the barrel down 1/2, down 1/2, down 1/2. I can use that to make more points. And then, solid or dotted. More ink here, more ink there. Additionally, if you needed to, you could subtract 2x from both sides, getting y is greater than or equal to negative 2x plus 1. Well, y-intercept of 1, down 2/1, down 2/1. Still works. Shading. If I were to put in 0, 0, I get 0 is greater than 1. Is that true? Since 0, 0 is not a solution for this line, I will point the other way, away from 0, 0. Option 2, if I'm in slope-intercept form, y is greater than the line. So go to the line, and the y's are bigger when I go up. So up. Same thing for this guy, except I can subtract x, divide by -1, divide by -1, divide by -1, getting y is less than or equal to x plus 2. Or x-intercept to -2, y-intercept to +2. Either way, I'm going to get the same line. Just depends what your jam is. Get enough points on there. More ink here, more ink there. And this says either 0 is greater than or equal to -2. That's a true statement. If 0 is greater than 2, if 0, 0 works, then I shade towards 0, 0. Because that's where my answers are. And we'll go make some more points. Option 2, this says y is less than or equal to the line. Go below the line. I see where everything is pointing. Everything over there. Okay. Now, you don't have to do all of that. I essentially just did that problem 3 times. Can you do it one shot? Subtract 5x, subtract 5x. 0 out, -2y, less than -5x, plus 6. Divide everything by -2. Getting y is greater than, have to flip the inequality, 5 halves x minus 3. Start at -3, slope of 5 halves, up 5 over 2. Or up 2.5 over 1. So I got enough room. Less ink here, less ink there. Y is greater than line. Go above line. Okay, it doesn't have to be this big, confusing, masterful work. A little bit of work off to the side, I got my line. It's already in slope-intercept form. I know what my slope is. I passed chapter 5. Less ink here, less ink there. Y is greater than the line. Go above the line. You should be able to tell where all those arrows are pointing. Okay, they're all headed up. Okay, so it really is just what you did before. It's section 6.5, but 2 of them. So that also means, along with that comes, can you work backwards? Comes, can you do words? So, I know this is going to look absolutely atrocious, especially when it's inverted colors like this. The way it looks in your book, because I know I've got at least 1 or 2 of these on your assignment. You all know your color pie theory, right? What happens when you mix blue and green crayons? Or sorry, blue and yellow crayons. You get green, okay? So what they're saying is the blue line is shaded this way. The red line is shaded down this way. The green is where they overlap. Okay? Which, when I flop colors, blue becomes red, green becomes purple, yellow becomes blue. Please tell me you've done that in art class. Like, have you ever noticed every time I poke the wheel up here, what's opposite of each other? Okay? Okay, good. Your art teachers did not fail you. Write a system of inequalities for these. So this is a double dose of what we started with. Start with, suppose I just realized that I'm going to say blue line, but if you ever have to watch the video, it's actually the red line. Start with blue to you, red to you line. Where's my y-intercept? 1, 2, 3, 4. Okay. Y is, where was it shaded from blue line? Above it or below it? We shaded everything this way, right? And since that's shaded down, I know it's less than. Will I make it or equal to? Why not? Less ink here, less ink there. I know there's an x. Now all you have to do is find the slope to it. So find two nice integer points that it goes through and say I went right this many, down this many. That was terrible. That kind of looked like, well, that looked like Dominic's writing. I went right 1, 2, 3, 4, and down 2. Well, what's right 4, down 2 as a slope? Close, because we always go to the right. The up or down tells me plus or minus. A -1/2. Okay, so I got that taken care of. Get that out of here. There we go. Go do it again. For orange line, which I suppose is, what, bluish on the video? Or on the regular one? It's shaded up from there. So I'll start with y is greater than. It's a solid line, so I make it equal to. I see a y-intercept back here of -1. And then I go find a slope for it. Goes up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So the slope is just, well, 1. So I just put x. Dead on. That's it. Like, that's your system. Suppose if you want to be formal, you put that kind of squiggle bracket in front of them, but that's just flexing. Try it. Down there, what's your y-intercept? What's your slope? Did they shade above or below? Solid or dotted? What's your slope? Okay, shouldn't be too terrible. Blue line, I see a y-intercept of 1. I see a dotted line shaded below, so less than. And my slope is down 1, right 2. So negative 1/2 x. Down 1, right 2. Orange line. Again, it's shaded below, but this time it's solid. So I put or equal to. I still see a y-intercept of 1, but this time I've got a slope of up 1, right 2. Up 1, right 2 is positive 1/2 x. Okay, so these just kind of mash together all the different line stuff you've been doing for, what, 2 months now? 2.5? And then, and Satan said, let there be words with math. There it is. Now A, if you're making a 2-variable linear inequality system to decide what to do after school, well, that's a choice. I want you to hunt around in here and look for our magic words. Totals, starting amounts, rates. Before any of that, did you go to the question at the end to find what your variables are? What is a graph showing how you can spend your time? Oh, well, they didn't say anything there. Read back through it. What are the ways that I spend my time in this problem? Basketball and homework. So, label those. Call X and Y. I want to put homework first because it should have come before the basketball. But I'm guessing a bunch of you are going to put the basketball here because they just said it first in the problem. Always label your variables. I wish I could take all the kids who are in Algebra 2 and beyond and go back to their early classes and pound that in their heads. It's that important. All right. If those are my things, then my equations, or in this case, inequalities. Do you see totals or starting amounts? Total of 6 hours playing basketball and doing homework. Okay? So basketball and homework. Basketball and homework. You can spend at most less than or equal to 6. Okay. Now this is tricky because there's not 2 inequalities, there's 3. You must spend at least an hour and a half on homework. Well, homework was just plain old Y. And I said that has to be at least 1.5. What is at least in Pac-Manese? Greater than or equal to. So that's this part. Blue was this part. You want to spend less than 2 hours playing basketball. Again, that's a choice. Less than 2 hours on basketball. So basketball was X. You want to spend less than that. Well, less than. Is it or equal to? Right? Less than 2 hours. Okay? Example, where's my student athletes? Hey, there you go. You're in track, right? Okay. What is your actual height? Not roster height, because we all know they lie on there. How tall are you?
5'3".
Are you shorter than yourself? Pretty stupid question, isn't it? Is 2 hours less than 2 hours? No. So don't put or equal to on there. Now there's 3 different things here. That's why I'm really not a fan of that shade it, shade it, shade it, shade it, shade it, shade it, then darken the living crap out of an area. I would rather do those little arrows because it's not as messy. Okay, so my X has got to go to at least 2. My Y's got to go to at least 1.5. Remember when I got these to make my scale, I should go find my X and Y intercepts? If I shove a 0 in for Y, I get an X intercept of 6. If I shove a 0 in for X, I get a Y intercept of 6. I got a 10 by 10 L grid over there. Do I got enough room? Yeah, I can just go by ones. So I'll label it like that. I'll say X is hours of basketball. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can get away with labeling every other like that. It's still going by ones. And this is going to be my hours of homework. Oh, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, blue line. X and Y intercepts of 6. Put your intercepts at 6, connect the dots. Solid line. Which way do I shade? Remember, the above the line, below the line thing only works if it's in slope intercept form. Now, it's not in slope intercept form because I can't say is less than the line because this isn't the whole line. I got to put stuff with it. Put 0, 0 in there though, and is 0 less than or equal to 6? So from this line, I will shade towards 0. Do you remember what y is greater than number looks like? Which way?
Sideways.
Right? Y for the horizon, X is for vertical. So I'm going to put a horizontal line at 1.5. And it says y is greater than or equal to that line, so I will shade everything above that line. Y's are bigger above it. And next up is X is less than 2. So we go to 2, make a dotted line, less ink here, less ink there. X's are less than, closer to 0. You see how that could have gotten really messy if I was using shade this, shade that, or doing the waffle thing. Dear God, if you did the waffle, the crosshatch on this, it would just be lines everywhere. But here, I can see where all those arrows are pointing. They're all headed into that little trapezoid in the corner. Anything in here is a valid answer. So I could do 1 hour of basketball and 4 hours of homework. I could do 1 hour of basketball and 1.5 hours of homework. It would be in that region because it's right on the line. At least this, you have this, yep. You should be able to write this. Before you go graphing the thing, let's make sure we all wrote it correctly though. Just a little bit of review for you. They're talking about a rectangular area and the fence around it. What are they talking about? Perimeter. So if you need to know off the top of your head that perimeter is 2 times the length plus 2 times the width, might be handy. This one's set up the same way. There's going to be one big equation that's got x and y. There's going to be 2 little equations that got x and x or y. Any of you got parents that work for the district? No? Just wondering if I can tie the whole parent portal for campus in with my teacher stuff. That bothers me and I'm not even doing it. Okay, do we have it written out? What is the graph showing possible dimensions of the dog run? Means I'm looking at x and y. You know what? How about this time I don't actually do x and y? Are you okay if I do literally length and width? Or base and height or something like that? Now I like that because actually you can get arguing about semantics. Would you call the x-axis length or width? Okay. Length? That's just feels weird to me because it's literally how wide it is on the paper, but we're used to putting length this way and width this way when we draw a rectangle. Just curious. I'm going to go x and y, length and width. Okay, it's what most of the crew said, so I'll do that. My different inequalities here. If I have 126 feet of fencing, what did they just give me? It's a total. So I know it's the whole 126x plus y thing. If it's a total, I can be less than or equal to it. And then they give me, the rate. The rate is actually going to come from the formula. I'm going to have 2 x's and 2 y's. I'm going to have 2 lengths and 2 widths, and that is my perimeter. And then it says can be at most 50 feet long. So x is at most 50 feet long. You have what else? 10 feet wide. So y is at least 10 feet wide, so greater than or equal to. Are you okay graphing it after that? Like, I think we're okay with the graphing part, but words into math seems to be where we get hung up. So I wanted to at least get that out of the way. Okay. Now, what can you tell me about the graph and about our scale? Can I go by ones on my x and y axis? I know I have to go out to at least 50 on the x-axis. But then you go up here and find your x and y intercepts. X and y intercepts are both 126 divided by 2, or 63. That means both my x and y axis have to go out to at least 63. I got 10 boxes. You got to choose now. What do you want to do? I like 10s. Could I go 20s? I think that the graph is going to start to squish down if you go into 20s. Could I go 10s on one and 20s on the other? Okay. So the scale that you choose is going to change the size of the graph. If I was doing this on my own paper, maybe I'd just go by 5s and have a bigger graph. Okay, so you get the choice. I'm not worried about that. We did that throughout all of chapter 4. We practiced to get in 5. We're doing it again now in 6. Guaranteed going to see it on your final. So right now it's, can you write that in here? Do you know how to graph the thing? Okay. Ladies, gents, and folks of all strokes, that's the end of the chapter. That's the end of new material. On Thursday, we're just going to get more practice in on this. Your assignment is already up on Planbook. There's only 5 problems. We're done with that. Thursday is practice. Monday is your last quiz. I am right smack in the middle of a grade-a-thon right now. My goal is that you know exactly where you sit before Monday. And then because you and pre-calc are both doing tests on Monday, I'm going to try to pound those out as fast as I can so you know going into finals week, 100%, this is where I stand, this is what I need on my final to get the grade I want. Okay? God, no, I need that for my mental health. No, I'm going to be spending all my evenings grading.